Hello everyone, I hope everyone is doing okay. Welcome to our session, Azure Back to School. Once more, I'm so honored to be here. And this year, it's really an honor for me to be selected among all these amazing speakers. So many thanks to the organizers of Azure Back to School, and of course all the speakers that are participating into this amazing event. Today we're going to explore something that I was very keen to explore myself. So I did learn something really important out of this while I was doing it hands-on. It's not a very extended implementation because I like hands-on things, but even this small demonstration that we're going to go through together, it's really uh, impactful, insightful, and allows us to learn more about AI and how we can transform our applications and our models to be better, to grab and get feedback from our users while they are using the models. And the bottom line here is that it's a brand new technology, of course, but it's not that you build something and that's it. Okay. More of that in a few. My name is Konstantinos. I'm calling from Athens, Greece. Thank you so much for being here today. I will be back with you in in 1 minute to to start. Thank you so much. Thank you everyone for being here with us. I'm Konstantinos Passadis, Azure Back to School 2025. My session is about boosting and tracking AI models using weights and biases, a third-party technology outside of the Microsoft ecosystem. I'm going to show you how we can get feedback for our RAG application, which we're going to build from scratch, and how this helps us understand how the model operates, how the model is getting liked, whether our users like it or not. And of course, on this basis, we're going to discuss a little bit more about uh, feedback loops and how models can become better. The application we're going to see is a RAG application, of course. We're using Azure AI search. We're using some sample website to get data into it. So we're going to see everything, and 60 minutes, I believe, are just enough to get through. So without further ado, I'm going to shut down my camera for now, and I'm going to reopen it later. Boosting and tracking our AI models, how we can enhance performance and how we can make our models better. This is the case here, and this is what we are trying to achieve. What we're going to do is a model that will be available, will um, have these thumbs up, thumbs down icons, so users will be able to provide feedback, positive or negative, and then we're going to see this feedback in dashboards. We're going to create these dashboards. Actually, they are already created for saving our time into the weights and biases cloud platform, where we're going to track it and see how that performs. A few words about the importance of boosting and tracking AI models. And it's all about the feedback, right? The feedback loop. You may have heard this sentence or this term. It is an essential operation, an essential element within the AI model or the AI application lifecycle for refining AI models and enhancing their reliability and user centricity. It helps us improve continuously our applications and, of course, our models with iterative feedback loops that help us align the AI behavior with the user expectations and actually what we are doing. Are we achieving our goals? Is our application getting the attention, the positive attention that we are that is meant to get, or we are out of our initial goal? We started to build something and we went the other way around. Of course, we need also to be mindful about the user experience, right? The feedback helps us optimize the performance and, of course, fosters adaptability and responsiveness. As fast as you can, the faster you can, return to your model, to your application, and enable those markers that guide you to say, okay, this is not liked by the user. This is where I got the most negative feedback, or this type of answer was not optimal as my users said through the feedback. So I have this field of improvement and I'm going to take advantage of it. So it's all about responsiveness. A few words about the actual term, feedback loop concept. It's the user feedback mechanism that we use, right? We're going to see that this simple thumbs up, thumbs down, you have seen it everywhere. It's the easiest, the simplest thing that you can integrate into your application so your users can easily provide their I like it or not engagement. And this is an insight for you. It's not just a simple thumbs up, thumbs down. It may look like something simple for the user, and this is the beauty of it because it doesn't cost anything to say, okay, this is something that I like, yes, thumbs up, or I don't uh, prefer this type of answer, or this engagement is not what I expected, thumbs down. We collect this feedback. We're going to do this actually. We collect this feedback and we're going to analyze it. So we will identify patterns, we will see the strengths and the weaknesses in our AI outputs. Getting this feedback insights integrated into our application is also something that helps us train and fine tune our AI models. Okay. And then our AI models are becoming more accurate, more relevant. Okay, remember, we are building not for us, we're building for others. I know that there is this idea that if you are into AI, you're building AI and it's all about you. No, we are learning to build for others. We are bringing better experiences. We are bringing faster experiences. We're bringing democratized access through AI for improved experiences and applications. And this is all about transparency and accountability. Remember, responsible AI. And this is where it comes into play, responsible AI. This is our framework, an ongoing assessment for us to provide transparent and be accountable about our AI. Are you taking into account what your users say? Or it's just you build something and that it's not uh, important to you. You build it just for you to build it or for other reasons. I don't want to go there. Yes. So what we are building, retrieval augmented generation, and we are going to use Azure AI Search for efficient indexing and retrieval of relevant data for our AI model. We're going to use Azure OpenAI, of course. GPT-4o is fine for this operation. Our framework is Python and Fast API that offers a lightweight and high performance framework to facilitate this operational. So you understand here that we're using a frontend that is a React frontend, a very simple white Vue React application. It's easy to fire up a React Vue application, so makes our life much easier. And we're going to implement weights and biases dashboards for visualizations, and we're going to see how this thumbs up, thumbs down is depicted into our dashboards, into weights and biases. Of course, it's not only about the dashboard, right? There are other ways to track this performance without the need to be uh, logged into their platform, but it is free. And this is something important. I have opened this account more than 3 or 4 months ago, and my account is still there. I hope it's also today. No, it's still there. It's working in the free tier, but I'm able to create amazing dashboards, amazing charts. I can say it's not the easiest thing. You need to spend the time there to understand the parameters, but you can build amazing informational visualizations. And I'm keeping something, a little bit of a surprise of what weights and biases offer through their library, through their package that you install into your application. There is no, there, you're getting more than just the metric of the feedback. You're getting more metrics, and you're going to discover this. We're going to discover this together. So let's work a little bit on our pre-demo presentation. I'm sorry. What we have here is we're going to ingest data that is coming from a blog, my an older blog that I had. We're going to get a specific page of it out of it. The page is going to come in a JSON format, broken down into 6, 7, 8, or 10 pieces for easier ingestion into Azure AI Search. Azure AI Search will be created with us. We will create it through our script, and we will load this data from our JSON in the form of pure data, but also we're going to create the embeddings of our data. So we're using embeddings. Why? We're using embeddings because we want our model to easily understand which um, element, which phrases, which words are better suited for the context that we are asking. So, in fact, what's happening there? We have an application and we're asking questions. The model is looking through the context to get the answers, and through with the help of the embeddings, it's able to get the context to answer us. And because it is a language model, it's creating a nice phrase, a human understandable phrase to let us know about the answer. When we get our answer, we're able to click the thumbs up or thumbs down icon, and in real time, we can see the iterations in the weights and biases um, platform. Of course, we can log also locally into our local workstation if you don't want to go on the cloud of weights and biases, you can do it locally. And you can also create local charts and visualizations. So yes, this is the case. Of course, we're going to return to our slides for more about this. And let's have a small break, and we are continuing with the actual demo. Thank you. Right, and we are back. Thank you for being with us at this point in time. We went through the presentation and we understood what we're going to build. Actually, let's have a quick look on the application and how it will look like. I'm not going to deploy it into the cloud. No need for that because we can see it very nicely locally. So there is no need for um, actual implementation. And I have chosen to go this way. The reason is that you are able to work any type of application without the need to deploy. And this is the beauty of modern application development. You don't need to go actually to the cloud. You know that, of course, most of you know it. So let's go. We just fired up our backend, okay? This is our Python backend. You can see that it is already logged into the weights and biases using an API key. In case you were not logged in, it will ask you for a key. It will provide you the um, the link to go get the key, bring it here, and continue starting your application. It's very easy to do it. There is also a lot of documentation that you can implement into your solutions, and you can refer to, of course, for your solutions. So let's start now our White Vue app. I don't know why I selected Vue. I was experimenting with Vue. Vue. I don't know how you pronounce it here in Greece. It's Vue. And I'm opening. Here it is. And I think you'll see here it is. It's very simple, right? But what happens in the background is the important thing. So let me see what data we have uh, uploaded. I don't remember what was about. So let me find the blog documents. It's about GraphQL. It's something about GraphQL. So let me go here and ask about the Apollo server. What is the Apollo server? Yes. And the answer has returned. Okay. The context is within our information that is uploaded already into Azure AI Search. And here we can provide the feedback. So if you saw earlier, when I just asked the model to um, provide the the information. Let me show you here what I mean. I'm sorry. Okay, so when we started the backend, this is what I was trying to say. When we started the backend, you see here that we have some links. So we're able to go directly to see what's going on into our weights and biases dashboard. Okay, we need to log in, of course. And I have an account like this, and I need a PIN. This is my local workstation asking for a PIN. And we're taking directly to my account, right? I have a project named RAG Demo, and here are my runs and the inference tracking. Here I have a number of charts. I'm going to remove the ones that are not what we wanted. I think I need to open my, yes, these are my charts. So you can see here I have 30 inference tracking. This is each time that we have a run response from the backend. Okay, you can see here each step and the response that we got, the feedback, how many um, feedback loops we got, and what it is about. Queries about key vaults, sentiment analysis, what is AKS sentiment analysis. You can click on it and go to the specific step, but because it's a very simple thing, you are going to see only this. The important thing is to go to your project and collect here all the charts that you are going to create. Now, this is a little bit of a tricky thing to do. You need to dig a little bit here to create the better charts that you are looking for. And of course, this is very basic. I haven't gone to the level that I was expecting, and probably this has to do with the simplicity of my application. Okay, this is just a thumbs up, thumbs down tracking. Okay, yet it remains important, but it is simple how much a visualization, how many visualizations you are going to get for such a simple thing. Okay, but still you have what you are looking for. The little surprise that I was telling you about in the beginning is that you are also getting metrics about your performance, and this is something that's key. Because if you combine this information of how your users respond to your model, and you have also the the picture, the timestamp of your performance at that point in time, then you have a 360 view of what's going on with your application and your model. Because, for example, if the users are very disappointed, you may find out a pattern that each time that your network traffic is degrading or something is happening, your users are not happy. So at that point in time, you understood that the key is your performance or whatever. Okay, this is just an example that I said about the importance of the feedback loop, but also the extra information that you are getting from the same package that it is installed into our local workstation that generates and brings into our screen the information that you need. So you can see here the bucket is running and we have continuous information. You can see here that wherever I leave my cursor, I'm getting parallel information about the other charts as well. So this is also important, right? And you can see here also this chart. Wherever I leave my cursor, I get visualizations, informational visualizations about disk, for example, utilization. Or here, um, again, I'm getting highlights. Okay, let me see here. I think we got something also here. on the line. Okay, very important. Each time that our backend has a run, it is with a different color, and I believe that you can also have here something like a number, an ID that is uh, gets ascending or whatever. I'm not sure about it. Okay, I'm not an expert on using this weights and biases board, but I can tell you for sure that you can do a lot of things. I believe that this thing that I was able to bring together just by reading it, it's quite important. Of course, you can add more panels here. You can see that you can do literally amazing things. Imagine the possibilities, right? By bringing also media in, you can do whatever you want to do here. Here is, for example, evaluation. I didn't have to click that. I'm sorry. Evaluation. So it is searching different things and it's telling me about uh, the different responses and the different iterations that happen through my backend. I can change the visual a little bit different, and the feedback was positive. Runtime, step one. This was step one, the first step for today, and this was step 7. Yeah, undo, undo. You can do undos. You can also add more panels with quick add, line plot, bar chart, scatter plot, parallel coordinates, custom, scalar, compare metrics across runs and highlight differences. Also, this is very important because you can apply your updates, your enhancements, and then you can still uh, compare what's going on. Parameter importance. This is about comparing hyperparameters. I think it's feedback type. No, something else. The step. Yes, I think I'm looking for the step and the parameters. Okay, I need to search for the parameters here. No, there's no like this correlation. Let's look what other panels can we have. Query panel. Here you create expressions. Okay, run summary, runs history, view summary. Okay, so how we build this? I can spend a lot of time working here. I'm sorry. So how we build this? First of all, we need our Azure subscription. Let me bring this up. We're going to go portal.azure.com and we're going to log in. Just give me a moment to. Okay, here we are. Portal.azure.com. Okay, we need a resource group and all we need in reality is this Azure AI search. Okay, so you can see here I have created this one, RAG 1DB EPAM, and that has this index. These indexes, let me delete the ones that are not needed so we can work on our index and add more data there than the GraphQL. We're going to take it from the scratch, as we said. I can also take you to create everything from the scratch. We can do this if you want to. I don't know if we have the time. Let me try that for you. Okay, we are using Jupyter notebooks. Okay, so let me show you. First of all, let's collect the data. Okay, we need to collect the data. I have a script here that does this for us, and the script is extract block. It's a Python script. All you have to do is provide your link here, and it's going to break and chunk this data. So you will be able to upload it easier. You make your life a little bit easier for Azure AI Search. So let me get a link from this blog. It's the Archive Cloud Blogger. Cloudblogger.eu. Sorry for this. Yes. And let me take you to one link, one post. Let's get one post. Okay, I'm going to get this, the ultimate guide to build your AI server with AKS. Okay, it's this one. Okay, this one. I'm putting the link into my script and I'm saving it. So I'm going to run it and it's going to collect the documentation in with this name. And we're going to upload the documents into Azure AI Search. Now let's run the file. Okay, it collected 42 documents. Let me find where is this. Yes, it's this one. You can see that it is what it does. It is does an append operation. So I'm getting this JSON copy and bring it here. Let me delete those and bring my new one here in the backend folder. Paste. Okay, where the backend folder? Okay, let me zoom in a little bit so you can have a better view of what's going on. So here is we are working in our backend. We run our first script that collects our blog post, breaks it out into chunks. So it's like a pre-processing for your embeddings. It appended our data, so we have ready. Let's create a new index in our AI search. Let me close this one and close this one. And let's go to our environment variables. You can see here that I'm using this search endpoint, and by this, what I mean, let me show you. It's this, right? AI search instance. Okay, it's in the basic tier. When you want to make some development practice, all the free tier is the best. Okay, I know it won't charge you, but sometimes you may need to go a little bit on the on the upper tier. So basic for me, it's the safe way to make sure that everything works. The search key and the search index. Let's give another name for our index. RAG BS school. I'm sorry, RAG school. Okay, RAG school is the name of the index. Let me save the environment variables. The OpenAI is this one. We need two types of models. The first one is a GPT-4o. It's the LLM in reality that constructs the answers that are coming back, and the text embedding model it's used to create and store the embeddings into Azure AI Search from our JSON file that you just saw. Let's go. We need to open our Jupyter. So here is our Jupyter notebook. I'm sorry for the coloring. It's a red and I don't like it either, but I don't know if we can change it. I'm not going to be on that place right now, start to make changes. We are going to lose time. Let me restart my backend just to make sure that it will load the environment variables, or we can leave it and load it later. So what we have here, first of all, we're working version later than one. There are changes that define, breaking changes that define whether you are going to use OpenAI packages one and upper or lesser than one. If you're going to use one and upper, you need to make changes to your code, or there is a process to migrate your code. Of course, you have Copilot that can use, can help you make the transformation. You need to create your Jupyter notebook because it's very easy to utilize a Jupyter notebook just to run code. In our case, we want to create uh, an Azure AI search index. So this is the first cell that we're going to run. We're setting the parameters. We're creating the client and importing the required packages. Second, we are loading the data from the JSON that we just fetched from the blog. And then we have a small diagnostic to make sure that everything is in place. Okay, the schema is there. Let me clear all outputs from the previous runs. And then I'm going to create the index. It's not this cell, it's the next one. Here is where we are creating the embeddings and we're storing them. I'm sorry, here is the first thing that we need to run to create the index. Okay, so let me clear all outputs. It's going to install whatever it needs. Requirements are already set, but never mind, I'm going to run it for you, clear all outputs. So now it needs specific types of packages for Python to be able to create our index, and we named our index rag. Let's be sure about what we're doing, don't make a mistake. Rag school. Okay, so it's rag school. Where is it? Here it is, rag school. So we're saying here, okay, I want to create a client. This is my endpoint. This is the key, and this is the index that I want to create. Get my client. Here is the client created. Here is the fields that we need. Let me create it, and then I will show you. There are different fields for different type of job. First of all, ID. We need the ID because we need to make correct indexing, and without ID, it's a string. You are into deep trouble. A searchable field named content, of course, it needs to be searchable because it will store the actual content from the blog. A simple field named category, this is, for example, Azure or M365 or whatever you want to name it. The simple field source, where you can store the source, the URL, where your data is coming from, whatever you want to store there. And the search field that is named content vector, and this is where our embeddings live and are stored. Okay, it's a search field data type collection, and it's a single, it is searchable, and it has applied a vector search profile that is going to be created a little bit down the code. This is my vector profile. So I'm using vector search. It's fast, and we want it just this one. Okay, we have also a semantic search, as I can see here. Yes, and that's it. And we're creating the index. Let's run it. Let's go and create the index, my friend. Go. The index rag school is created. Let's see what happened. Indexes here. Refresh, refresh. Here it is, rag school. Let's see that everything is in place. The fields are here. Yes, everything is here. Later we are going to see why this is unchecked and what's the difference if we check it. If I search, there's nothing here. Okay, nothing. This is what it has. You can also run JSON queries, very important, especially if you want to troubleshoot your RAG application. Very, very important to be able to run JSON queries on your Azure AI search instance. Okay, we need to load the data. The most important part. Let's go. Again, same logic, different cells, and that's the beauty of Jupyter notebooks. You can break down your snippets based on what each part of the operation, so you can have better control and visibility. What's happening here? We're importing the required packages. Again, we are loading the environment variables. We are setting the OpenAI configuration for Azure. You can see here the endpoint, the model, the embeddings model. We're creating the client for our search index, and this time we are setting the index from the environment variables. We are loading the documents, as we said earlier, a simple diagnostic that everything is there, and then we are going to create the the content, upload it, but first it will pass through the embeddings model, so the embeddings will be created. Let's see. We need to run the first cell. It is successful. Let's load the documents. Okay, a little bit of a diagnostic here. Yes, yes, everything is there. This troubleshooting doesn't, we don't need it, but we need to go down here. So we're going to upload our documents from our just loaded into the memory block documentation, and you can see here that it's creating the embeddings and it is storing them in the content field that we just created through our search index. And you can see here what else is loaded from our JSON file this time from doc. You can see here doc, right? Doc equals the JSON we just loaded into the memory, right? Let's do this. And we can see here the print, it will print out whether we failed or we did it. Let's go. Yes, I think it will make it. It has a connection error. Why? Oh, what? Why? Failed. Connection error. Why we have connection error? This is really important. Why we have connection error? Did I forget something? Everything is there. Did I forget something here? No. Block documentation is correct. Failed for connection error. That's really strange. Let's retry. Load. OpenAI point embedding is there. Search endpoint, search index. Yes, search key. Okay. Start our kernel. Sometimes the kernel needs a restart. It may have cached things or whatever. So run this once. Okay. Load the block documents. Good. Diagnostic is correct. Rag school. Yes, this is the one. Rag school. Fields in the index ID content category source content vector. Yes, recreate the index. I don't want to recreate. My index is there. I have defined everything. Let's upload. I don't like this one. Why we get connection error? Rag school. It's correct. Connection error. Let me make sure that I'm using the correct keys and everything. In my environment variables, I mean, okay? This is what I mean. So let me find here. Okay, this is correct. Let me get to once more the key, copy. Okay. Oh, here it is. Here it is. I found it. Something, something got into the way here. The demon of the whatever, and make our life go figure. Okay, okay. We found it. Some characters came into here probably from a mistaken operation or something. I don't know. Let me save that. Okay. Let's do that again. We just need to upload. Okay, I'm going to run this. I need to run from the start because it's defining here the parameters. Imagine what can happen, especially in live demos. I saw it in a flash, right? I could have not be able to see that and just wonder what happened, why happened, and all the stuff. Let's try again. We go down here, clear all outputs, and run it again. I'm going to restart again. So the stop, interrupt, restart. OpenAI.azure.com. I think that I'm correct here, right? Rock School, yes, and yes. Let's go. Okay, here. Okay, let's make the diagnostic. Doesn't it will? Okay, Rock School is correct. Yes. So you saw what happened here. Keep that in mind. You are learning from my, not mine. You are learning from the intricacies of the system. You need sometimes to restart the kernel because it holds the environment variables from the previous runs. Yeah, keep that in mind. So we just uploaded our data. Don't spend time here. A little bit of AKS about cloud native and Azure AI server, a custom AI server on Azure, and Graph API, GraphQL API, very useful for our AI applications. So we have a lot of data, a lot of context. We have just created our Azure AI search with content. Let's see what's going on here. Let's go to our indexes. Remember, it needs some time to reflect the actual document count and the vector index quota. So don't panic if you don't see data taking space. But if you perform a search, you're going to see that you have data. It needs time, especially if you're doing it via the API programmatically, to reflect the numbers on AI search. If I add this to retrievable and go to this, I need to save and go to the Search Explorer, you will see here that I will be able to see also the embeddings. Here are the actual embeddings for each record, uh, phrase, context. Okay, so let me return back. Non-retrievable, I don't want it. Let's go. So we have our AI search ready. Okay, what do we need now? We need to start our backend. Our backend, let's have a quick look. Is this one, this main API. It's importing the correct packages, allowing origins for the case. It will load all the environment variables we just used in our Jupyter notebooks. It will use the same search index. It will use semantic search, and I think somewhere is a vector. Here are the two endpoints. The first endpoint is the API query when we press ask, and the second endpoint is the API feedback. When we press one of the feedbacks, thumb up or thumb down. Let's start now our backend with UV core because we are publishing an API. And it started. It connected to weights and biases cloud instance, and here is our project, and here is our run. Okay, we're going to see that. Let me run also now our front end. I think we have started it already, if I'm not mistaken. Somewhere here, no. Let's restart it, not any problem. How we are restarting our front end. It is already started. I'm clicking here and I'm getting this link. Refresh just to be sure and ask something. Um, what can we ask? Uh, okay, what is model context protocol? This information is in the blog post about the custom AI server, one of the pairs of one of the contexts that we just, and you can see here that we have sources. Okay, our context and our application is created in a way that it can provide also context. Where is this data found? If I leave it here, uh, yes, I didn't complete it. Yes, the reason is I don't want to send my user in the AI search. I should have been able to provide the context either by bringing the specific part where the information was found from the content or send them to the URL where the context is found. Okay, let's go. Another question. Okay, I don't like it. I don't like the answer. Okay, what is a case? So the model is using the context and is providing the sources. Okay, we haven't implemented this part in an actual implementation, but it's there to see in a true RAG application, you're providing also your sources. And in our case, we're not giving any files, but we're giving just links, just to show that yes, it is a RAG application, and yes, the context is taken from the AI search. In the previous quiz that you just saw, information was created by the OpenAI general knowledge. Important information just to keep it. And I provided two feedback loops. And let me go to the project. We have it already open if I remember correctly, but never mind. Which biases. You will see that our inference has gone up to 32. Yes, correctly. Let me go to my project, select the default. It is saved here. I lost my panels. Oh my God, I hope not. I don't want to collapse. Okay, here is the query panel. No, the evaluation that you just saw and the charts section. You saw how easy that was. You don't lose anything. Okay, so here is our latest, I think, three inference tracking here. Let's see where it is. What is AKS and what is the Apollo server? Our latest um, answers, right? Also, the inference tracking is here in the chart. As we saw earlier, you can see here how much time it took and the answers for each inference. We're in 32 right now. So if I provide one more answer, let's go. What is, again, Apollo server? The context is there, it will find it and it will provide sources. It has three sources to provide. Thank you very much. I like that answer. Let's go back here. Give it a moment. It needs, mm, it's almost in real time. I can say that with confidence. It is almost in real time. And the system, of course, here. What is AKS? What is the Apollo server? No, it's a little bit later. Yes, here it is. It just came up. If I click it, I will be taken to this exact specific point in time with this specific information. And if I wanted, if you have more information, we could add more charts. So this specific answer could have provided you more insights regarding the feedback that you just got. So this is the one. This is the gray. Yes, this is the one, the gray one, which I can select. Control C to copy tooltip. Okay, this is our inference right now. Positive user feedback, index and index versus created. Yeah, it's very interesting. I'm not an expert here. I'm saying that again. I'm still learning, but I was able to create something that makes it's useful. It makes sense to me, and of course for someone reading it. September 5, yes, it's this one. The last one we got. Let's get one more. What is what we can ask? Let me check this. Okay, what is a backend server? Very generic question. Let's see what it will answer. Yeah, very nice. Very nice. You can see here that it's combining. This is this is right to the spot of what the RAG application can do. It's combining the context from both blog spots. It doesn't care where it comes from. It has the context within Azure AI Search. So OpenAI uses the information, it reads, and it gets data. It is able to combine both of the context it already has at hand and provides us with an answer. This is really amazing. And we're going to see here the, the next one. What is a backend server? Now, I don't know why it has to do with the time here and time. This is index 11. Ah, okay. This is index 0, index 1, index 5. The C axis is the index. Hmm. And here is the step. Really, really nice. Create a timestamp. It will go up, of course. Latency, relative time. Okay. Very, very nice information step. And the color will be created timestamp. You understand here what's going on, right? You can see the beauty of just that symbol, um, thumbs up, thumbs down, what you can create out of it. I wish I knew more about this type of information, how we can make it even better. But yeah, amazing. This is the feedback chart, and this is the step chart. This is per inference. So we're already here in uh, seven steps. Yes, the metric is step. So each run, each time we provide an answer, it's a step. Uh, Metric is the step. 10 rounds maximum. We can do it vertical, of course, but it's nicer in that case like this. You can, okay, relative time. Yes, you can have an axis here with the relative time or even and the latency. Perfect. You can write your own expressions. You can, amazing. So thank you so much for being here. I'm a little bit over time. Let's have a quick break and return to close this session. We'll be back in just one moment, just 1 minute. Thank you. And we're back. We're back to close our session. First of all, I want to thank everyone for being here and being patient enough to stay until the end of this session. I hope you got something out of it. You learned something. I did, and that's why I submitted this specific session. I learned a lot through this demo workshop, and in reality, I'm going to be a little bit more onto this. I want to understand better uh, what's the business uh, benefits of getting these visualizations. I wish I had people that have been already there and already exploring uh, visually the fine tuning of their models. So if there is someone among the audience that's already doing it, please contact me. My information is publicly available, of course, and the easiest way to find me is either via LinkedIn or through my GitHub page, pasadis.github.io. This is me. Yes, and all my details are here, and you will find here a lot of projects, including this one and other projects as well. Really, really nice projects. And I'm also open to contributions. Microsoft Hackathon is here. It's, the Garage Hackathon, one of the most important hackathons for 2025. So I'm participating with the project. If anyone is interested, by all means. Many thanks to the team Azure Back to School for having me this year. I wish everyone uh, a great day, a great afternoon, or a great night. Bye bye. Thank you so much for being here.